Executive here at IDEX Solutions, and today giving the presentation will be Wes Russell, also of IDEX. Next slide. Wes, are you out there?
I'm here. Do you see the next slide?
I don't. Oh gosh, sorry, there it is.
Okay, good.
A little bit about IDEX Solutions. We've been around since 1996 as a Dassault Systems partner. We sell all of the Dassault brands, including CATIA, Innovia, 3D Via, Delmia, and Simolia. We also do implementation services, custom and process development. We're a full-service contracting shop. We specialize in automation and training. Next slide.
The next slide, we start my agenda.
The next slide is turning it over to Wes Russell. Wes Russell is our manufacturing specialist, and in fact, one of the best manufacturing specialists in CATIA manufacturing in the country. So with that, I will turn it over to Wes Russell. Wes?
All right. Thanks, Susan. I won't go into a long background, but it's been 40 years this year since I wrote my first NC program. So there's not a lot of slides in this presentation. Most of this is going to be a live demonstration of V6. So just quickly, a couple of slides on the agenda. I'm going to start by actually starting a V6 session. Because it's slightly different than starting a V5 session, the fact that you need to log in, I thought I would explain that a little bit. We're going to take a look in the Innovia database and using Innovia to do some searching and exploring data. I'll then go in and, because this relates back to V5, and most companies today are, if you're producing aerospace parts, you're receiving V5 data for the most part. V6 is slowly starting to get out there. I've seen customers receive V6 data at this point. So we'll look at importing V5 data, and because this is manufacturing related, I'm actually going to bring in a V5 process document. We'll replay and look to see, the structure in V6. Beyond that, I'm going to then, the bulk of this presentation will be creating a new NC program in V6. I'm going to start that by importing some product and parts from V5. We'll incorporate that into then V6 assembly. We'll do a little bit of assembly design, not a lot there. We'll then go into the machine programming workbench, which is in V6, it's under the Delmia brand. So we'll actually create a new program. The things that are incorporated into that is I'm going to bring in a machining cell that's predefined. We'll talk about that. We'll add a couple of operations. I'm not going to show you every machining operation out there, but you'll get a flavor for how we put a program together in V6. We're going to post-process the G-code. We're going to do some machine simulation from that G-code. And lastly, again, the data is inside of Innovia. We'll look at, the last thing I'll do is exporting the G-code data. You need to export it from the database to get it out to your machines. So with that, we'll go, I'm going to switch screens here, and I've got to close a few windows first. And let me cancel that, and so we'll start up a new V6 session. So like starting V5, you have icons on the screen that you can start from. The difference is in V6 is instead of your session starting up, you have a login screen. So it's necessary to log in. Let me start this login process. We have some options available, which as this is logging in, I'll explain. The data source that you see is basically connection information that is used to connect to your Innovia server. You can have one or more Innovia servers defined under data source that you can connect to. Obviously, I need a username and password. Once you provide the username and password, there's an options panel. Under the options panel, you can specify the role that you want to play, and that role gives you different access to the data, what you can do with the data. The other thing that is involved when you log in is that the available licenses are presented to you, and we have the ability to verify that information under the help menu once we start in our session by going into the function here, PLM user information. Opens up a panel. I can see what security contexts are the roles that I have available. We can see what role I'm currently in. I could look at what licenses I have available and so on. When you initially start a session, by default, this quick start window appears. The quick start window shows me some data that I have recently accessed. So the first thing I'm going to do in here is, because Inovia is working on top of a relational database, it offers advantages over file systems and folders that most V5 users are familiar with. So I thought I would start out here by doing some searches in Inovia. At this point, I have a client connection, and by the way, I'm running off of a laptop connecting to my Inovia server, which is on a VMware virtual machine. So the screen layout a little bit is, you notice the menu functions that you have available. So at the top of the display, you'll see a set of menus. We also have a PLM toolbar where this circular green icon you may be familiar with. It's the equivalent of the start menu that's in V5. Then we have some other functions available here. One of them is the bar search. So I'm going to start by using the bar search. So within this field, I can type in the type of data that I want to search for and a string that I want to use to look for it. So because this presentation is basically manufacturing related, I thought I would look for a product that is a, let's see if I spell it right, a tool holder. And this string can be part of either the part number or name of the part, any portion of the string that you want to specify. When it performs the search, it retrieves that information and it tells me how many results that it found. In this case, I found one tool holder that had tool holder in its name. And so, for example, if I select this, and let's say, for example, I wanted to delete this tool holder, so this icon is the delete function, it opens up an incident report, because basically what it's telling me is that this tool holder is instantiated outside the scope of deletion. So if I were to delete it, it would obviously affect wherever this tool holder is used. So I just wanted to point that out, that if you try to remove things from your database that are linked to other objects within the database, it's always looking at that, and it'll let you know about that. So this tool holder obviously is in use. I have a function in here that I can actually explore parents. And so this particular tool holder, which it indents this list, this tool holder that I searched for is a component of all of these tool assemblies. So it's basically showing me where this tool holder is used. And if I expand this tree further, let's say on this 3/4 end mill right here, this 3/4 inch end mill tool assembly that's using this holder is used in this machining cell, which is used in this NC program. So the example I'm using is for a tool, but this would work with any type of object in your in your database that you wanted to find out where used. And I point this out because if somebody wanted to look in V5 for show me every NC program where this tool is used, that would be a difficult task in most cases. It'd be quite easy here. Okay, so you'll notice that the search results come up in a tab, and if I perform different searches, I will get more and more tabs. I can create new tabs, I can remove tabs, go back to the Quick Start tab. Okay, let's take a look at a different tool holder. By the way, it remembers recent searches that you did. So if I click this up arrow and I look for a search I did here on it happened to be a tool that started with 500 for the diameter. So I perform that search, and there's a number of results, 13 in this case, that came back. And let's look for, let's take a look quickly at this tool assembly. So in this case, these are just search results, but I'm going to go into the Explore function and explore what's in that tool assembly. Now again, this is just in Inovia. At this point, I'm only interacting with the Inovia database. The graphic that comes up is the default graphic that's used to represent the fact that this is a tool device. So every object has a type, and if you don't give it an image to use, it's going to use a default graphic to show that. Obviously, this is a tool assembly, and you'll notice the icon here tells me the fact that it's a tool assembly. So as I start expanding the assembly, I can see that I have different objects in here. So this kind of gear-looking object, again, it's a default graphic that is indicating a representation, and then I have two other tool devices under there. So within this assembly structure. So one of them is the tool itself, and if I expand the tool, we can see that the tool that's inserted into this assembly is made up of, again, a representation and also a default cutting. So this is the cutting portion of the tool, and a default no cut that you see here, which is the non-cutting, or in this case, the shank of the tool. And these are defaults. Every tool has at least two, because you'll have a cutting portion and a non-cutting portion. In V6, we also have the ability to define maximum wear on a tool, or if you send that tool out for regrind. So we can have a separate or another pair of maximum wear for the cutting portion, and the shank as well, I suppose. And then in this assembly, we also see another object here, which is the tool holder itself. So again, this is the default shape. So if you simply define a tool holder in V6, or even if you read it in through V5 data, it's going to actually create parts and assemblies in V6. So this is the single gear here represents a part. So this is the default holder part. And in this particular holder, the reason I explored this one is because I've also added a user representation, which is another subassembly in this structure. And the user representation has a collet and a tool holder. So on the display, when I use this tool in CATIA, we can view it with the default holder and the default tool, or we can bring in a user representation. And in this particular case, I've only brought it in for the holder, but you can also bring in user representations for your tools as well. So it gives you a little idea of the type of information that we can search for, as well as how tool assemblies are built up in V6 as well. Again, so this is simply opened. I'm exploring this. I'm still in Inovia. So this comes up as another window, which I can close that window. I'm back to my search results window. I can also close that tab. All right, so the next piece in our agenda is the ability to import data. So from the PLM Access menu, I have the ability to read in 3D XML is typically V6 data that I've exported from a database. I can import files. I can import CATIA files. So CATIA file import represents any V4 or V5 CATIA data, V4 CATIA data. I don't think I've got any V3 data left to import, but I believe it would work for V3 data as well. In this particular case, I have some V6 files. Let's see, let's go to a different folder. Let's look at this one, for example. And here's a process file. And just to show you what it's going to bring in this process file, the part operation is linked to the product, which is linked to a couple of parts. So I'm going to ask it to import the process document from V5, and I'll say OK to the import process. So what this does is it looks at all the objects that are linked to that process. In this case, the product, which is the NC setup product, which contains a part and a stock part. It could have fixture components. It could have any number of other V5 data in there. This is all the data that it's going to import that it saw from, here's the structure that it's going to bring in. And we'll go ahead and import that structure. Now there's other options available. There's mapping tables that will allow it to look to see if any of the data was previously imported. Remember the tool structure that we just looked at. So any of the V5 tools that are defined simply as parameters inside of the V5 NC program are now going to be assemblies with other parts in V6. So it'll build those structures as well. So it looks like I'm bringing in 4 different V5 documents into V6. As a result, it's going to create quite a few V6 objects in the database. But now all those tools can be reused in other NC programs. Okay, so there's an import report. As long as the message says it's okay, everything is good. I can expand the tree under this, and if there were errors, typically I would do that to find out what errors I would have. There are a few restrictions, especially when you import process objects. The documentation points these out. For example, if I had tool paths that were external to the process document, that's a restriction. You would want to internalize your tool paths. You could simply remove the tool paths, and it's not an issue. A little bit about, now we're in the machine programming workbench. So this is now V6 Delmia workbench. You see the structure in V6. So the activities process tree by default floats. I can dock it if I wish. You'll notice it's also kind of like a heads-up display. You can see through it. You can change its size, obviously, and location on the screen. The tree structure that we're used to, we still have over here, although the structure changes. It's also a heads-up display type, so I can look through it, but I can also control the size. The F3 key we used in V5 to toggle that on and off still works. There's an additional V6 function. I can click on this, which it'll just hide it or fade it into the left edge of your display. So all of this data came in from V5. Here we see the tools that were used. These go into a resource product, which includes the definition of what I had defined in the part operation for the machine in V5. You can right-click on this information. If I go to NC Resources, I can edit those resources that were basically the setup of the machine. But in V6, there's additional information in here. So some of these tabs you'll be familiar with from programming V5 manufacturing. We have the spindle and tooling tab, compensation, and so on. Under the numerical control tab, that's all fairly familiar. We can also add user variables in V6. We can also define the output generation. So normally in V5, we only saw the NC output when we actually went to generate output. In this particular case, you can have that stored with your machine information. So a particular machine needs a specific type of output. I can control that here, and it will be remembered for this particular machine, as opposed to specifying it every time you're generating output. So this program that it read in is ready to be replayed. Like in V5, I can access it either via contextual menus, or I can use toolbars. So here I can do a replay on this function, which it'll recompute the toolpath, and I can, standard replay capabilities. You'll notice the panel looks very much the same as it did in CATIA V5. If I chose to go into material removal simulation, I can select that icon. I didn't have these toolpaths updated in V5, so when I go into simulation, obviously it has to update the toolpaths that are prior to the operation that I'm on. And then it brings up the window, and I have my mode set so that it stops at each tool change, and I can replay and control that. So I won't spend a lot of time with that. Again, I wanted to show you the similarities between how you perform these tasks in V6 versus V5. Okay. So when we're done with this information, we imported it in. If we want to make sure that everything we've made changes to, updated toolpaths, and so on, the equivalent of saving your file in V5 is to propagate it to the database in V6. So it's telling me it needs to be updated because I didn't update everything. And once the update is complete, it's showing me the different objects that get stored to the database. All right. We're done with that task, so I'm going to close this window again. Brings me back to our quick start window. So the next task we're going to perform is to create a new NC program in V6. So again, from PLM Access, I'm going to create a new product. So I use PLM Access. In this case, product is one of my options. So now this opened up the assembly design window in V6. And if I turn my tree back on, here's my product branch. And I'm going to go into properties for that because this is going to be a new NC setup, so I'll just name it that, new NC setup. Give it a description. So in this setup, remember in the agenda I said that I had some data that I wanted to bring in. So I want to insert some V5 data into this V6 assembly. So again, I'm going to import some new V5 information. Let's see, we're going to bring in, let's see, make sure I get the right folder. Setup, yeah, I think that's okay. So in this case, we can bring in this product. And we'll import that, a product in 2 parts. So here's the structure. The only thing you'll see that's different here is instead of constraints in V6, they're referred to as engineering connections. We'll look at those in a little bit more detail yet. Again, this is another window. When I did the import, this came into a new window. So I'm going to simply copy this assembly and switch to my window for my new NC setup. And in this new setup, I want to paste that as a subassembly. And let's move that up to the top of the display. This is the update function. So when I see that that needs updating, I want to update that. And so we have a subassembly in our new NC setup assembly. So then I want to insert some an existing subassembly that I have in V6. So I'm going to right-click in here, and in this case, I want to insert an existing product. So I have to search for that product, and I searched for it before. So I can go up here, and it's a Stevens plate that I want to bring in, and so I do the search for that. So it found that one. So that's highlighted, and I can then ask it to bring that in. By default, the way my settings are set up, it wants to establish a position when I bring that in. In this case, I'm just going to cancel that and let it come in a default location. And these are kind of laying on top of one another. But this is a riser plate and a couple of Juergens dovetail blocks that I'm going to use to hold this, that I use on a particular machine frequently. So we're going to use that. I want to move these around out of the way a little bit. Let's see. Let's bring this which way? Let's go in Z. Let's move it in Y maybe. Back there about. Okay. All right, so engineering connections. They're different than, or actually offer a lot more capabilities than the constraints that we had in CATIA V5. Basically, if you look at engineering connections, it's a lot more robust. What you see here is, other than simple constraints, we actually have kinematic joints. So what they've done is consolidated the fact that in V5 we had numerous workbenches that would allow you to generate kinematic connections. In V6 they consolidated all of those under assembly design. So if I wanted this to be go into the kinematics workbench, I could add the kinematic joints in assembly design. Same thing when I build an NC machine. I can put the machine components together and define the axes or the kinematic joints of the machine in assembly design before I go into the machine builder workbench. So in this particular case, I'm going to start by fixing. Typically, I would fix my my part and my stock. So if I expand the tree, so here's my part model. I want to fix that. I also can generate a fix constraint for my stock model and update those. And then I want to use a different type of connection. In this case, I want to use a rigid connection between my between the fixture that I'm going to mount the part to and the subassembly for the part to be machined in its stock. So in this particular case, you notice here that it says position first component. So I'm going to position this piece up to the bottom of the dovetails. And when I do that, you'll notice it moves into position. I want to also constrain the dovetails themselves. The dovetail on the fixture with the stock, and I also want to position it lengthwise here as it fits into the V. By default, it makes these parallel. I don't want them to be parallel. They should overlap a bit. So I can go in here and I can replace that with an offset constraint. You'll notice here that it gives me then a dimension, which I can double click and enter. In this case, I'll offset it 1/4 inch and it moves accordingly. So there's my, oh, well, that's okay, I think. Okay. So there's my NC setup. At that point, I'm ready to take this NC setup into the machining workbench. So much like V5 worked, I can right-click and see an icon of my favorite workbenches. If I click on the workbench icon, I get the dialog box that shows me the different icons. You'll notice that some of them changed. Here's, for example, my machine programming workbench is this new icon in V6. Okay. This machine programming wizard comes up by default. You'll notice here I can not have it appear when I come into the machine programming workbench. Basically, it guides you through what steps you need to take next. In this case, you'll notice if I put my cursor over these icons, it shows me what function I need to access those functions, and here it explains what they do. In this particular case, I'm going to load a machine configuration that already exists in my Inovia database. So if I click on this function, it shows me in the wizard, it shows me what function I need to access. Obviously, you're going to remember those in short order, and you can then disable that display. So this lets me do a search for this machine. So again, all I need to do is enter a part of the string that I want to use. You can use wildcards anywhere inside the string before and after the string. I can do a search for that. So it found one machine that matches this. It happens to be a Morisiki NMV5000 is the machine. And so when I say OK, it then brings that machine cell actually in from the database. So a machining cell, that's a new concept in V6 as well. A machining cell not only contains the machine, which could be simply the definition of the machine as we would fill out the tabs under the part operation. It can also have a machine model. In this case, I used Machine Builder and have the machine built. So I can bring in the machine fully built if you want to do machine simulation. The machine can also have, or the machining cell can have accessories for that machine defined. In this case, when I stored the machine last time, I had a machine accessory, which is a riser mounted to the table. So instead of my Stevens plate with the V blocks, I had a riser for a different setup. you can access these machine accessories either straight from the database, or you can actually leave them in your machine definition, and each time you use that machine, you can tell it what accessory you want to use for this particular setup. If I was to mount my part at this point, it would mount it on top of this accessory. I don't want to do that. I defined a setup that I want to mount it straight on the table. So the first thing I'll do here is unmount this accessory. So it takes it off the machine and it puts it to whatever location you defined it in. I can hide it at that point if you don't want to see it. It happens to be down at the base of the machine. Or I can actually just remove it from my machining cell. So I can right-click here and say, delete unused resources. So that resource isn't used, I can remove it. Let's close the wizard at this point. I don't need that. The next thing I want to do then is mount my setup on the machine table. So this toolbar, I'll move the machine out of the way here so you can see it. You know, in the V5 machining workbench, we have an awful lot of icons. All of those have been condensed to this grouping. And this grouping has actually more functions than we had in V5. But a lot of them are very similar or the same functions that we had in V5. This one happens to be new. NC machine control gives us some functions. Some of these are common. Machine control could be post-processor instructions or access system changes, head changes, and so on. In this case, I have a function to mount my workpiece. Mounting workpieces typically is done from an access system. Now, the machine itself can have one or more mount points. In this particular machine, I've defined a single mount point, which is the center of the rotary table. So this dialog box wants to know at what point of my NC setup do I want to mount on the machine. So I can click on this icon and select one of these two access systems that I have, and I want the lower one happens to be at the bottom or the base of this Stevens plate. I want to mount that access system as my work mount one on the machine. And again, I mentioned this machine only has a single mount. If I back out of this and say apply, it puts that access system where it knows the machine mount point is. You can define as many different mount points on a machine as you want. For example, if I had a 4-axis vertical machine that had a rotary table bolted onto the end of the table, I could have a mount point in the center of the table. I could have a mount point in the center of the rotary axis on the end, the 4th axis. You can define, again, as many as you want, and you can choose those off of a list if they have more than one. The options panel lets you adjust it. So based on this, if I wanted to then modify the, if I was going to shim that up a bit or for whatever reason, I can adjust those coordinates at this point. Okay, so here's my NC setup on the machine. And by the way, typically when I build a machine, I remove all the covers. There's no reason for having the enclosure on the machine. You just have to either open the doors or whatever. I also added some holes on the side so I can view this from more locations. This is actually in this machine itself. This side is solid and the far side is actually the tool change arm comes in from this side. So, but I've enlarged these holes so it's easier to view. Okay. Let's see. If I expand the view on here so that I actually can see the machine itself, I can simply right-click in here, and as I'm programming, quite often I'll hide the machine itself. Okay, so under the part operation, just like in V5, I want to double-click on my part operation to open up the part operation dialog box. Within this, I can specify the part itself. So I can use my pre-selection navigator functionality to select the part. I also have some additional pieces that are actually in the stock model, but I'm going to use those when I rough this out as a portion of the part itself. And then double-click in space, and the part's defined. My stock is this block. Fixture components, I have a couple of fixtures. I'm not worried about hitting the table, so I'm not going to select that, but I could add that as well. The axis system that I want to use in this particular case for this machine, this axis system happens to be the center of this table and the center of the B axis, which is typically where we put 0 on this, and we're going to end up making this the G59 work offset. So I'm just going to define the axis system as that. And we'll say OK to that, and we're OK with the part setup. Okay, so after that I want to add, again, I'll keep this short so we have sufficient time here. I'm going to add a couple of machining operations. I think I'll start out with a roughing operation. So the way these menus work, you'll notice each one of these has some number of functions. If I switch the main menu items, these are surface machining operations, which actually include all of the 3-axis, 3-, 4-, and 5-axis machining operations that are available. So as you see these toolbars, there's additional functions down here. Let's put in just a roughing operation initially, and I'll try to do this quickly. So I'm going to just use the part that I have already selected. I am going to specify the bottom, which is the top of the fixture itself, but I want to offset that. Give it 30 thousandths of clearance. I'll rough this to within 100 thousandths. Let's go over to the Tool tab. You'll notice some differences here in the Tool tab. We can look for tools that I already have, whether they be tools themselves or tool assemblies. So the button with the 3 dots are tools or tool assemblies that are already in the machining cell. So if you load a cell that has a predefined set of tools, you can recall from that list. I can recall tools from tool catalogs. The catalogs themselves exist in the Inovia database, but there's really no reason for a catalog in this particular case, and I can search for tools or tool assemblies straight out of the database, which I'm going to do in this case. So in this case, I'm going to use a 3/4 end mill, so it's going to start with my naming convention, start with 075, and I have a number of those. This machine uses an HSK63 holder, so I'm going to pick this assembly and say OK to that. In V6 at this point, I can display that tool if I want to see what I just called. I like to remember or tell you to remember to turn it off, otherwise it'll stay there as you're using it. Just like in V5, I have more options, so we can look through the different tabs, look at the compensation registers, and so on. You'll notice that this was already defined, so all of this information is predefined with the tool description that's in the database. I've defined the geometry already. A little bit of cutting information. I'm going to do one way outside and change the tolerance and give it a depth of cut and maybe turn high speed on, and that's good enough for this one. Hit replay. So you'll notice once you're in the dialog box, programming in V6 is very similar to V5. The way you access the data, replaying the toolpath, and so on. So I won't go through replay at this point. Yeah, we'll call that good, and I'll say OK, and we have a roughing operation. Just for the sake of speed, I'm going to add just one more toolpath. Let's put in a multi-axis flank contouring operation after the roughing. Again, very similar. I'm going to use the same tool. We zoom in here. I'm going to hide the stock. And I want to select these 3 faces. You'll notice here it's warning me that these features are in different parts. You'll notice this is drives 1.1, this is 2.1. I don't want to see that warning in the future because then I have a 3.1. So I can use those. Notice these arrows, the vector's flipped. I want to be on the outside of that face. I'm going to use curves as part surface in this particular case for these three. Let's see, I want to stop relative to this end. I'm going to stop out. I'm also going to finish out relative to this end. I'll give it an inch of clearance. Tool axis, I want to modify that by minus 100, not minus 1, minus 0.1. Yeah, I did get the decimal point. Okay. And what else do we need? Step over, I want to cut one way. I'm going to step over 100 thousandths, and I'm going to put 3 passes in. Tool axis, and that's good enough. Some macros. Let's activate approach and retract, and since I put 3 levels in, we're going to activate return in a level. So for my approach, I'm going to feed in tangent, and I'm going to come down a couple inches along the tool axis, and let's make this a 1/2 inch. That's for approach. Let's see, let's copy that as well. That was, what did I do? Oh, I was on a different one, wasn't I? Okay, well that's fine. I'm going to do the same thing here. I just did them backwards. Tangent in feed by a 1/2 inch, and a couple inches along the tool axis. That's what I meant to do. Similar for the retract. That's what I meant to do. 2 inches, and copy that. Okay, so if we replay that tool path, I forgot to do that. Okay, little local modification. This looks very similar as well. So on this first one, since we don't have a good connection between these two, the stopping condition is going to be tangent to the drive surface. Then we're going to restart in a forward direction, and actually that stopping direction is also going to be tangent drive surf. And the last component there will be forward direction again, and replay would probably work better that way. All right, so there's our tool path. Let me, while I have the tool path up there, let's turn the machine back on, and if I'm replaying this tool path and I stop the tool path at a cutter location, at this point I'm not simulating the machine, I'm only replaying the tool path. But if the machine is loaded, I can check reachability, and so it then puts the tool in the spindle and does a static check to see if the machine can reach that location. And you'll notice here the dialog box that appears, it does say that it's a reachable position. So at this point it's just checking the machine's travel limits. So you can do that static check without ever doing a machine simulation. All right, so that operation is good. So then I want to, with what we have, I want to post-process the data. So this function lets me generate the output. take a look at the tree here, because the output that we generate, since everything else is set up, I can just tell it to post. I have this set up for an IMS post and also a controller emulator that I can simulate the machine then from the G-code that we generate. So the app source is done. We're now in the post-processing stage. You'll notice that it added whatever the name of my NC output is. It added that information to the tree. It also displays, and this is a dialog box you can have turned on or off, but it displays that there were no errors or warnings in the app generation and no errors or warnings in the post-processing generation. So it's nice to have this be displayed, because I don't need to open up the log files to know that everything was good. That information goes into this branch, and if we go down here into the NC files container, we can view what files are in there. So there's a log file for the lowercase log file is the log file generated from post-processing. The uppercase log file is generated by CATIA for the app source. We can look at any of these or view these files. If I select one and say view, I can look at the code that we just generated. Again, it's viewing it from Inovia at this point. If we want to simulate the machine, there's one other piece of information that I need, and I'm going to go to the manufacturing program to specify that. I want to do an NC code-based simulation. It needs to know where, in this case I told it I wanted to use G59, it needs to know where that is. So we're using work coordinate system G59 for this NC program. I need to specify the coordinates from machine 0 to where G59, which is at this axis system, is going to be in this program. Now, this axis system happens to be beyond the travel limits of the machine. If it were within the machine travel limits, I can simply click on the icon and click on the axis system. Because it's beyond it, I can enter the coordinates. In this case, I wrote them down in a text file. So I can just copy from there and say, well, the Y component is going to be this distance. You'll notice the spindle move as I update these coordinates. So that then the next is the X coordinate. Copy that. Goes in the X field here. That brings it to the center of the rotary. Then the Z component. Z component goes in this field. So in this way, I say OK to that. I've got G59 defined. If I have multiple work coordinate systems on the machine, I would go through and define all of them in this dialog box so that it can accurately simulate the machine. Once that's defined, I then have two different options for doing machine simulation. I like this one where it does using NC code line, and I'll show you what the line part of it means. So it brings up machine simulation. Again, I'll toggle that off and I'll make this window larger. We have a simulation player. There's some other simulation options that I can enable. Here we see the part and the stock in the machine. The line simulation lets me specify in the G-code where I want to start simulating from. It doesn't have to be the beginning of the program. I could start at this tool change. I could start when the tool gets to after it picks up the length comp and approaches the workpiece. So if I click on block 150 here, N150, it puts the tool in that position, and I can begin my simulation from there. I like that capability. You can do this as many times as you want. If I stop the simulation, we can do that as well. So we have a speed control here. Unlike V5, V5 machine simulation works similarly, but other than, or unlike simulating from cutter locations, here we're simulating by slices of time. So it updates this cutter position, in this case, every 1.5 seconds of movement. And so the simulation player shows us how many seconds into this tool path we are. So if I change this to 10, we can move through here faster. At any time, you can stop and pause it. You can see what block we're on now, 16,480, and continue forward. Okay, we'll get through here to the end pretty shortly. Let's see how we're doing on time. Well, we started a couple minutes late, and it shows me I've got 3 minutes or so, which should get us through, and hopefully if we have a minute or two to, if you have any questions, we can open it up for that. Okay, so the simulation is complete. This is the only surface that I finished, and you can see the finished surface of the part. Again, if I wanted to replay the last cut over that finish, the reason I use this simulation option is I can scroll backwards here. Just looking through here, I know this is where the tool was at the beginning of the last cut. When I click that, since it's so far down in the program, it has to look and update the graphics. So it recomputes to get to that point. So here's where the tool was actually approaching that last cut. And I'll slow the simulation down again. Let's make this 1, or how about slower than that, maybe 0.5 every half a second, and hit forward. And we'll look at that last pass. Or maybe that's a second to the last pass. That's what it looks like. Okay. So I can close the simulation. Even after I close the simulation, the ISO toolpath panel stays active on the screen, and any toolpath that I highlight with the cursor, it will put the tool at that position in the toolpath. So if you want to do any static checks of cutter locations, you could go back through the program that way without going back into simulation. Okay, so that takes me down here to the end. A couple of things. First of all, I haven't saved any of this data yet. So again, saving the data, we would go through and we would propagate this back to the database. It says I need an update. So we do the update. Then we have the propagation panel. There's a few options that you have available in here. In this particular case, I just want to save everything. So it's 23 objects that I have involved in this program. If we turn our tree back on, and the last thing I want to point out here is the fact that in order to get this NC data to your machine, you need to export it from the database. The advantage of the fact is that your toolpath or your computed not only the app source, but the post-process G-code data is in the database, means that if you make a change to it, you can also revision your NC code as well. So it's controlled in Inovia, and if I wanted to version this, I can do that as well. To get it out so that you can send it to the machine, I can do an export of the NC files container. I can put it here in my temp folder, say OK, and it does an export. And if I go look at my temp folder here, let's see. Oh, that's mail. That's not that. I want to go to temp, and let's look at what was current here. So again, here's the files that were in my folder. Here's the toolpath. So if I want to look at that in Notepad, for example, there's my NC program. Okay, that brings us to the end of this presentation. So at that point, let me go back here and open it up. If anybody, we have a minute or two maybe, if anybody has any questions.
Thanks, Wes. That was a great presentation. Are there any questions from anybody out there? There's quite a few participants. That was a lot of good information.
Can you hear me, Susan?
I can. Who's speaking?
Hi, this is Paul Welton speaking.
Hi, Paul. How are you?
Doing pretty good. Unfortunately, I was not able to get in until towards the end, and I was just wondering if there's any way that I can view this later online.
Nick, did you record this?
Yes, this webinar is being recorded, and I can email it out to you.
I appreciate that greatly. Thank you.
Not a problem.
Do we have other questions?
Wes, you just talked too well.
That's good.
I have a question. Can you hear me?
Yes. Who's speaking, please?
This is Mitch Jardine.
Hey, Mitch.
How you doing?
Good.
The tool management. You selected a tool holder, and it automatically selected the associated end mill with the holder. Can you maintain a separate tool holder catalog and tool catalog?
I don't use catalogs very much in V6 because the data has to be in the database even to put it into a catalog. So why maintain both? I can as you saw in the icons, I can either access them from a catalog or directly from the database. So most of the time now, I would put the holders in a database, and I can search for a holder, and I can marry that holder up to any tool. So there's, I didn't get into, because of lack of time, I didn't get into it, but there's a, in the tooling functions, there's a tool assembly function that lets me query a holder, query a tool, assemble them, and put in the gauge length. And it actually shows, you get a little panel with a graphic, and if you change the gauge length, you see the tool move in the holder. And then, of course, that assembly is then saved back to the database.
That's exactly what I needed to know.
All right.
Can you query by machine then if you have a work cell that has set, say you have 200 tools that are, 200 cutters that are set up for that machine? Is there a query to query by machine?
You could, yes. You notice when I first loaded in the machining cell, which again the cell can have the machine accessories. It knows what post-processor is needed, and it can have a predefined set of tools. So whatever you put in that cell, when I query a cell, like if it's a given machine, for a given, I queried one and it had one, but it could have brought up 20 different machining cells that were different configurations of that machine with different sets of tools, and they're all accessing basically the same data, but it's unique to that cell. Does that make sense?
Yes, and actually that's pretty good because that means for different materials we can have different sets of cutters.
That's correct. Gives you a lot of possibilities.
I do have one question about AppSource. You were posting directly. Is AppSource still available for post-processors that are not available through CATIA?
Yes, you notice when I looked in the NC files container and even exported it, it's still exported and maintains the AppSource file. That's no different. And by the way, PP tables and post-processors for V5 work exactly, unaltered for V6.
That's
so you don't have to change anything there. Any other questions, or are we out of time? Thanks very much, everybody, for attending. Susan, any other words?
No, I just want to thank everybody for attending. If you have any questions that come up in the interim or after you hang up this call, please don't hesitate to contact either myself. I'm Susan Crowden at idexsolutions.com or Wes Russell at idexsolutions.com. And we thank you guys so much for attending. Have a great rest of your day.
Thank you.